So the first thing I do when I start a proof, I don't start writing anything maybe except for the given, but I want to figure out where I'm going first. If I want to prove that DE is parallel to BF, the only way I know to prove things are parallel is maybe I can find some angles. I would love to know if these two angles were congruent, then those are alternate interior angles, and so those lines would be parallel, and that would be wonderful. So can I prove that these two lines or these two angles are congruent? Well, I would know those two angles are congruent if I knew that these big triangles are congruent, this guy here and that guy there, because if the big triangles are congruent, then all their pieces are congruent. So I'm like, okay, well, can I prove those triangles are congruent? I know I can prove triangles are congruent by side, 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 angle, side, angle, angle, side, angle, side, angle. Basically, I can prove it by any way except for donkeys. Donkeys are bad, but that's about the only combination, donkeys and backwards donkeys, that don't do me any good. So what have I got? I know that, oh, this isn't the given, that's what we want to prove. They gave me that AF is congruent to CE. So they're telling me that AF is congruent to CE. There's a side. Wonderful. They also told me that this thing is a parallelogram, so I know a lot of stuff then. I know that opposite sides of a parallelogram are congruent. That'll give me that side. And I also know that opposite sides are parallel, which helps me because then I could say that these two angles are congruent, because if I have parallel lines cut by a transversal, the alternate interior angles are congruent. So now I'm looking at my triangles and I think I have enough. I've got sides, then angles, then sides. So I've got side, angles, side congruence going on. And that's going to unlock everything. Because once I can prove the side, angle, side, then I'll have these angles by CPCTC, corresponding parts of congruent triangles are congruent. And then I'll have these lines parallel because of my parallel theorems. And so now you just have to write out everything we just said. So we've got our given, and our given was that AF is congruent to EC. Our next step was saying that AB is congruent to CD because opposite sides of a parallelogram are parallel. Oh, are congruent. Sorry. And I'm kind of abbreviating things here just for shorthand, but on the test you're going to want to write everything out. Just have to do it once. We also said that AB was parallel to CD because opposite sides of a parallelogram are parallel. And that allowed us to say that angle BAF was congruent to angle DCE because if parallel lines cut by a transversal if parallel lines are cut by a transversal, then the alternate interior angles are congruent. Whew. And so now we're looking, and we have every part explicitly stated in our proof. There's our side, there's our angle, there's another side. So now I can say that triangle BAF is congruent to triangle DCE by side, angle, side. And normally the next step after proving triangles are congruent is normally you're looking for one of their pieces, and we were looking for those angles there. So I know that angle DEC is congruent to angle BFA because of CPCTC, corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. If the triangles are congruent, then all their pieces are congruent. And our final step then is to say that DE is parallel to FB, because if alternate interior angles are congruent, then the lines will be parallel. And that is my proof.